Welcome back to Wickerson Studios. My name is Michael Wickerson, and now that I have a better system for recording, I think I can relax a little bit and take my time a little bit on these things. And we will continue with the GhPython scripts within Grasshopper. And in order to make it interesting and to make it mine, I'm going to take some really basic scripts in Rhino script syntax and in Rhino geometry. They're coming from a textbook, or at least they're inspired by the textbook that I'm working on, the GhPython textbook that's been created here that I just shipped in. As most of you know, it came out of Taiwan, and it's pretty exciting to see the contents of that book. But instead of just regurgitating it in English, not that I can read Chinese, but I can read coding, and I believe that's most people's second language, so we can communicate kind of across the internet. I'm going to have some fun, and I'm going to start color coding these a little more. I'm playing with a little analysis tool here, which is curvature, I believe, and I just pulled it into a render and showed this object that was made. That object has been baked from a single iteration, so if I left that and actually took off, you can see this object that actually exists here. I'm going to pop that over to shaded and show you what's going on. And then I'm going to take that form itself and put it in invisibility. This is the old technique that I used to do, and it stems from 2 points. And in doing so, there's our object. There's our parametric form. This uses a Python script, and I'm going to put the Python node in red. And what you see looking at this Python, we'll focus that right off the bat in these scripts. And I'll provide them on GitHub afterwards, after I do a dozen or so, and then I'll put them up. Basically, these tutorials are to get you thinking in the Python node and moving. If you've substituted Grasshopper for working Rhino, why not use Python to work within Grasshopper? I'm going to try and record this video, and now Ella's starting to act up a little bit, Mom, so maybe we can quiet her down for a minute. It's just about dinner time around here, and it's been a long day. So you go into your Python node, and I had shown this earlier, and everything in yellow is going to be my parameters that really adjust this, either before or after the script within Python. And I've written it twice here. I've written it once in Rhino script syntax and once in Rhino geometry. So if you wanted to comment out one or the other, that would be totally fine. So just shift, comment, triple comments, and right before you import Rhino geometry, you've managed to put that away. And I'm not interested in Rhino script syntax as RS. I'm trying to make a transition of myself and my mind jumping over to Rhino geometry as RG or any namespace within Rhino developer, which you can see online. Pretty simple script here. I am also going to import Rhino geometry as RG and import math, and I'm going to try and incorporate that in the script a little bit. And whether I do that before the Rhino component or after it in Grasshopper, you'll see how I apply it into the script. The form there is actually driven by this node in Python, and if we take a look into it, you'll see that the type hints are integers. Y is type hit integer as well, I believe, and so is Z. I do want to just make sure we're seeing our object, so give me a second to pop that off, and you can see our object whether it's selected or not, what I choose to select. What I've done is you can see the transition of going from Rhino script syntax as add point XYZ to Rhino geometry as point 3D XYZ. And what you're getting in Rhino geometry, and I've said this several times, is a geometry. You're not getting a GUID. So sometimes you need a GUID, so we'll go back to Rhino script syntax, but I think we do better to convert Rhino geometries in Rhino common to GUIDs when we need them. The second point that I generated is coming from the math sine X, the math cos Y, and Z. And those are inputs that I put in here as a slider from 0 to 10, 1 to 4, or 0 to 4, and 0 to 1.00. The reason I did that was because I was playing exponentially up here for this point. Now, I just remembered, 1 point is written in Rhino script syntax, and 1 is written in Rhino geometry. So I need them both running to get 2 points to actually make this geometry work. At least I believe so. No, I'm contradicting myself again, which tends to happen when you're alone on the computer looking at yourself. So I should be able to run both points out of here. It's just, it's not getting a very interesting exponential point. So let me just slide this around and see if our geometries change, and they do. We've got a nice way of playing with the geometries to the sine and cosines. So I brought those points down. We've got a nice geometry that changes the scale in the y, and we have a very interesting point system that changes it in the x. But I've made a lot of these points parametric and interconnected to the code that comes after in Grasshopper. Enough said with the Python node. I hope you can figure that out from what I did. I put on my first point output and my second point output, listed them as first point, second point, and defined my first point, second point by my RG, point 3D, XYZ, and my RG, point 3D, math at sine X, math at cosine Y, and Z. So let's be done with that. And I will show, the point of this is to start thinking in Python, to start thinking of scripting. I could have done this in other means, but I'm happy that I did it and incorporated it. I hit OK, I ran the script, and I downsized it. And here's our little cool geometry. And now it's become disconnected because of some of the points I played with. And I actually like how it runs right at 7 because it interconnects. And what I did was I took those 2 points that are within here, 1 and 2, put a line between them. I grabbed the starts and ends of those and put a sphere on each end. What I used that sphere to do, and I should go in and use my bifocals tool, is I used the solid intersection of those spheres and what I've actually created from this range and these geometries in a variable pipe. So I can play once again, not in the Python script, not prior, not with the maths, but actually play with the graph mapper on that range to get some very interesting shapes. And I'll even go in here and blow it apart with a parabola kind of plan. I'll pull it up so I have no zeros, so there's not a conflict of Boolean unions or whatever. Play with this shape here, make it real wide, take that whole shape and do a solid intersection between that and the circles. And what I'm getting is exactly the same form because the circles are so big with the numbers I have there, it's not really affected. But everything is interconnected as I move it and play with it. And what's nice with that, and it's not that slow a script, I can start to play with some very cool geometries with these graphs. And that's how I'm going to make these genuinely fun and interesting. Because the main point here is to get you in and writing in Rhino script syntax over to Rhino geometry and using maths within the Python node. Not too worried about it because I've got my breps that do fun things. And what I did was through a pretty typical, nothing special, and why is my polar array not saying polar array? That's very interesting. Let me just activate. Well, that's what happens. I grab those two, I throw them through a interesting polar array, and I end up with this crazy geometry that's come about just from that. And I don't think I ever would script something like this dealing with algorithms, but for those that began in something like Tinkercad or Tinkercode, you'll find there's so many beautiful algorithms that become enticing for young children to play with. And I'm just going to grab that geometry and bake this one because I think it's interesting, and I am running a hide function here. If you're in the Rhino command line and you try and do anything in Grasshopper while there's something active there, you're going to have no success. So here we go, back over to the render. Leave your Grasshopper by clicking on this view, only draw geometry when selected objects, and don't select anything. And now we have an object here, and I believe we have our original object. And we've ended up making something fairly interesting. We can select this one and put it to a emap, and we can just give that a second to load up. And then we can go back to that other form and go into, if I move my beautiful face, sometimes it just disappears while I'm recording. I'll take it into a surface and do a draft angle analysis, and not as exciting as the, let me select that again and go back into what we had because I do like that that curvature angle analysis is kind of a red and playful form. And that is doing something from 2 points in a Python node that are completely parametric. The script can be shared online, and I'm going to do stop or red, yellow, green. So stop with the Python node, have a look, open up your editor, and try and understand the script. It's dead simple right now for beginners. This is going to get incredibly complex as we process this book. But because I don't want to just regurgitate someone else's simple shared algorithms that are basically intellectual property that everyone should have within themselves, I wanted to customize something in Wickerson Studios and produce these pretty interesting scripts that pair along colorfully with a kind of curvature edit and emap of things that I would absolutely never make in the Rhino window. Probably would make in the Grasshopper canvas, but now with Python, I'm going to practice my skills of putting the lines, the ranges, the endpoints, the spheres, the points, the solid intersections, the graph mappers. I don't know how I do that, and the polar arrays. The one thing that irritates me here is I'm just going to take this and take that node bifocals and disable it, and then I just want to go back on and enable it, because sometimes you get weird little bugs, but maybe because this is in a bubble, I'm just not getting my bifocal tool working with my polar array. But you see things like that all the time. Let's throw it into a little end turntable because I'm not in a rush anymore at 10 minutes. I can record 12-hour videos now, and I know none of you want me to do that. But please have a peek. Enjoy this. I will continue this series. I thank uh, Bob McNeil for posting my latest 36-minute video and sharing it on LinkedIn. This community is growing. What I am doing, there is a need of. I know there's a need within my own students at the Kansas City Art Institute to consider digital, computational, and possibly more meaningful, optimized, generative art forms than this. But we need to start with a parametric model that hit this CAD from another angle and take our things to fabrication. Loving the effects of the lights on this. I'm never usually, and I must admit, digital design has made me a much more optimistic person. If you look at my past artworks at wickersonstudios.com, you see I've been built in kind of decay and entropy and disillusionment and all this stuff for 30 years. This has allowed me a community of people that is very optimistic and tending towards the future, and I'm looking forward to working with companies in new ways and commissions in new ways, and showing that instead of slide iterations of single sculptures to go forth for proposals, I can send on these small video loops and showcase my ideas as a designer. I actually really like this, and it didn't look anything like this before I did this little online video. Thanks very much for watching and supporting Wickerson Studios. I may go to Patreon. I may go to third-party things. I may take some non-disclosure agreements. I don't know what the future lies, but what I am doing is I'm teaching at a pace that I needed to learn at. I'm still learning through this process, and I hope to assist. And I've received some incredible international commitment and support since starting this site. So if you need a pickup in the day and you're doing something like coding and scripting and getting bogged down in it and want some creative ideas, let's get online, let's share it, and let's have fun together. Thank you very much for watching.